Hello, welcome to Reverse Engineering course. In this tutorial, I will show you how to convert new 3D scan data into a solid CAD model using Geomagic Design X. In part 1, we will import the scan, create region groups, align the mesh, extract blade profiles, and generate the first blade surface. You can also import the scan raw data from import, or also you can drag into Geomagic Design X. So this is our raw 3D scan data. We will work on it. Now we will switch to region group and click auto segment. The software automatically divides the mesh into different curvature based regions. It's processing. Here you can check. Software automatically divides a mesh into different curvature based regions. So now we can click anywhere where we want. Before I start creating CAD geometry, it's important to align the mesh correctly to the coordinate system. I will go to Align and Interactive Alignment. Click on Next Stage button. Here I am using the planar regions and cylindrical region from the mesh to define my alignment. The idea is to line up the fan with global X and Y and Z axis so that all future sketches and dimensions are easy to control. I will choose planar face to define a primary plane. Here you can see. Then use a cylindrical region to define the rotate axis. So once the preview looks correct, I confirm the alignment. So region and click on OK. Now the fan is centered and properly oriented at the origin, which is a best practice for any reverse engineering project. Next, I want to capture the blade shape directly from the scan. For that, I will use mesh sketch. So go, here is sketch and here is the mesh sketch. Click on it. First, I want to offset this plane below side. So press Ctrl and drag it below. Now I will mesh sketch on it. Mesh sketch allows me to take a section or silhouette from the mesh and convert it into 2D sketch curves. So click on the plane where you want to mesh sketch. So this is for move the mesh sketch up and down. And I will position the sketch plane so that it passes through the blade and then I extract the blade outline from the mesh. Hide the mesh. You can see that the software is following the scan geometry and giving me a clean curve to work with. If you can see the sketch is clean, then you can use auto sketch command here and just click on the curve. It will convert it into sketch profile. I can simplify or smooth the curves if needed to get a more controlled profile. Now you can draw a line, trim it, sorry, corner trim, select corner trim, and then this sketch will become the base shape for my blade surface. Moreover, this sketch should be inside the cylinder. So now click on Exit. Now I will extrude the sketch up to the front blade region, this region. Here you have to select up to region. And instead of extruding to a fixed distance, I will extrude up to the front blade region on the mesh. So click on opposite side and up here is up to region and click on this region. This lets the surface follow the real scan geometry more closely. You can see how the extruded surface now matches the front side of the blade. Just click on OK. You can also check the result from this side. Here is deviation for body. Here is the result. Now for this side, hide the solid body. Now I will make surface on this side. So go to mesh fit command and select this region. You can extrude the surface here and click on OK. It will make a surface on this region. Now I will cut the solid extruded surface to this mesh fit surface. So now I will click on cut surface and here is this is tool mesh fit surface. Now target body is our main solid body. Click on next button and click on remaining body which you want to remain. So I want to remain this body. So click on it. It will automatically remove this side. So don't click on this side. So click on OK. It will automatically remove and this body has been created. So hide the surface. Here you can check and deviation for body. This is deviation. Now you can see we have a clean solid plate that matches the scan geometry from both the front and the back sides. This is our master blade and we will use it to generate the remaining blades of the fan. Next we need to define the rotation axis for the fan. I will extract a reference vector from the cylindrical region at the center. This cylindrical region represents the true rotation axis of the fan. By extracting a reference vector from it, we ensure that the blade pattern will be perfectly aligned with the real scan. Now I will create the remaining blades using the circular pattern command. I select the solid blade as the feature to pattern and I use the previously created reference vector as the rotational axis. I set the number of instances to 3. So make the angle 360 and equal spacing. It will be distributed into equal spaces. Click on OK. As you can see, the software has created 3 equally spaced blades around the axis. This completes the basic blade geometry of the fan. Now that we have completed the blades, the next step is to model the center hub of the fan. This one. For this, I will again use Mesh Sketch to extract accurate profile. Hide the solid body. Select the plane. I select the appropriate plane passing through the center of the fan, and now I start creating the sketch directly from the scanned mesh. Now I will make sketch on this mesh sketch profile. So use line command. First I will make lines on the mesh sketch, then I will trim and close it. Now use trim command here and corner trim already selected. One line is missing here. Now use trim command and corner trim. Somewhere on scan data, scan is not good, so therefore we will ignore these lines. Now make radius. We will make radius here. This. You can fix these two lines so that these lines cannot be make radius on mesh sketch. Center the center line so that we can revolve around it. Also, I will make outer sketch first, then I will extrude cut it. So make a line. This line trim to this line and this from this. First we will make outer sketch and this line will be trimmed to this solid line. Exit the workbench. In this sketch, I have created 3 different profiles. These profiles represent the outer diameter, the middle step, and the inner hub shape. All these curves are taken directly from the scan, so the final geometry will remain very close to the original part. Now I will convert this 2D sketch into a 3D solid using the revolve command. I select the sketch that contains the 3 profiles, and for the axis of revolution I use the same reference vector that we created earlier for the fan rotation. Now show the solid part, and you can see. I enable the merge option so that the new revolved solid automatically merges with the existing bodies. Now you can see that the cylindrical center hub has been created and merged with 3 blades. At this stage we have the basic overall shape of the fan blades plus the main hub. Next we need to remove the inner material from the hub. You can check in mesh file. Now I will use revolve the cut option. Select the sketch. I select only the inner profile from the same sketch. Again use the same rotation axis, and this time I enable cut instead of merge. Here you will tick the cut, click on OK. hide the sketch here. Now the unnecessary inner solid has been removed and we have a hollow center hub that matches the original scanned shape much better. In the next and final part, we will add the remaining features, apply final cuts and finish the model with fillets. Now we are in the final stage of the fan modeling. At this step, I will again use Mesh Sketch to extract the remaining feature lines from the scan. Select the plane and move it up. Where you can see sketch is better. Click OK. Select lines. Here will be 3-point circle. I select the required face and start sketching the lines and curves directly on the mesh surface. Power trim and fix the line and extend, make line here and trim these two lines and close the board. Also make the line here and trim this one also. These curves represent the additional geometry around the hub that we still need to model. Now I will rotate this sketch into 5 more. Select on it and click on circular pattern. This arrow will be in origin. Extend these. Six. Close to the origin. These curves represent the additional geometry around the hub that we still need to model. Since this is taken directly from the scan, the shape will stay very close to the real physical part. Now I will extrude. Now I will convert this sketch into a 3D feature using the extrude command. I select the sketch and enable the merge option so the new geometry becomes part of the existing solid body. It will be fit here and tick the merge and click on OK. So you can check this is our new. Now just make we extrude cut here. So again click on mesh sketch and we will mesh sketch here. These are two parallel lines. Now make a circle in the center. And trim extra features. Fix these two lines because we will extend for cutting. Close these two endpoints. Also these two endpoints. Open the mesh file. Now I will cut it. Here extrude command, opposite direction. Check here. Apply cut here. Okay. It will be cut it in solid body. Here you can see. Now last is to make center hole here. So again click on mesh sketch and move it down. Click on OK, mesh and solid. Now I will make 3-point circle. Exit the workbench and make the through cutout on this. Also you can delete it and convert entities this circle. Join the 2 points and make a circle. We will cut it throughout. Extrude command. Check on cut command and click on OK. Here is one hole missing here, so we will again mesh sketch on it, move it down when sketch appeared, so click on OK. You can also click on auto sketch, it will be converted to circle. Move it down, extrude, opposite direction here, up to this region and check on cut, click on OK. So our model, 3D model is ready from scan data. At this stage, the model is now ready for further design changes, manufacturing or 3D printing. So this was the complete workflow converting 3D scan data into a solid CAD fine model using Geomagic Design X.